Hello and welcome to another exciting lecture for research methods. In this lecture, we're going to talk about non-experimental designs, so the quasi-experimental strategy and the non-equivalent groups experimental strategy. So looking at our learning objectives, so we're going to start by differentiating what non-experimental and quasi-experimental designs are. Then we're going to start talking about non-equivalent groups. So we're going to explain the difference between equivalent and non-equivalent groups. We'll do some within subjects non-experimental and quasi-experimental designs, so explaining pre and post non-experimental and quasi-experimental. Then we'll look at cross-sectional, identify when cross-sectional designs should be used. Then looking at longitudinal, identifying when longitudinal design should be used. And we'll finish up with identifying the statistics and terminology of non-experimental and quasi-experimental designs. Let's get right into that first learning objective. That first learning objective is to differentiate non-experimental and quasi-experimental designs. So the main distinction between these two types of designs is basically it comes down to the degree which the research strategy limits confounding variables and controls threats to internal validity. What do I mean when I say that? I mean that when we're talking about non-experimental and quasi-experimental, we're not talking about true experimental designs. You'll recall true experimental designs really control for confounding variables. They look at internal validity and try to do everything possible to control threats to internal validity. In non-experimental and quasi-experimental, those are not as strict as with true experimental. And then when we go even farther than that, a non-experimental design makes little or no attempt to minimize threats at all. And this whole no attempt, I think that's pretty harsh to say no attempt. It's more of less attempt. Less is a good word here. Less attempt to minimize threats, understanding that the type of design it's doing is not going to be able to control those threats. Quasi-experimental, on the other hand, does make some attempt to minimize threats to internal validity, and in some cases it gets to almost the same level as a true experiment. So quasi-experimental, it's going to be a spectrum, but you've got your level of no attempt to limit internal validity, large attempt, if we're just going to call it like this, and we've got this spectrum here. Well, on the no attempt or low attempt, we've got non-experimental down here. On the right side, at the large attempt, we've got true experiment. So at some point, we're going to have this cutoff with non-experimental, and everything else that's in between these 2 points is going to be quasi-experimental. And that is because in quasi-experimental, we can't ever control everything like a true experiment. So we're not going to get all the way to the right. But we are making an attempt to have an actual research design. So we're doing more than a non-experimental design. Non-experimental design, yeah, like I said, some control might be done, but oftentimes it's just collecting data without any effort to worry about internal validity. So what ends up happening is non-experimental and quasi-experimental designs, they often look like true experiments. It's often the case where if you look at them on the surface, they're the same thing, or they're similar. The studies that can produce groups of scores that can be compared for significant differences, so you can get differences between 2 different groups if you're checking 2 different groups. The biggest difference when we're talking about this, and this is going to be mainly in our quasi-experimental here, the biggest difference is that we don't produce groups by manipulating an independent variable. So if I'm looking at what drug treats pain better, drug A or drug B, and I assign half the people to group A and half the people to group B, well, in that case, it's a true experiment because we are manipulating the independent variable. In a quasi-experimental, we are not manipulating the independent variable. Instead, the groups are pre-existing. And a good example here is gender. If we're trying to see if there's differences between males and females, we can't do a true experiment. The closest we can get is quasi-experimental. Now we can make a quasi-experimental experiment that's basically as strong as experimental as a true experiment, but we can't, it's not technically a true experiment. So, because we can't assign people to gender. Another one I always like to use because it's a good one that shows that we can assign people to it. And that is pregnancy. If we wanted to compare pregnant women to non-pregnant women, we can't assign half the participants to be pregnant. We can recruit participants who are already pregnant. We can recruit participants who plan on getting pregnant. But we can't assign, as a researcher, we cannot ethically assign people to get pregnant or not. Which brings us to our second learning objective. And our second learning objective here is explain the difference between equivalent and non-equivalent groups. So what we're talking about here now is when we're looking at this non-experimental or quasi-experimental between subjects designs where the groups of participants are basically formed under those conditions, like I said before, where the researcher can't assign individuals to groups. The researcher can't assign people to be male or female, can't assign people to be pregnant or non-pregnant. So the researcher can't use random assignment. The groups then become formed, but they are non-equivalent. The big thing there is they are non-equivalent because they're usually pre-existing in one of the two conditions. And so the researcher has no control over it. The groups then may experience different conditions or treatments. If we're trying to see the difference between men and women in, let's say, spatial reasoning ability, is the difference then, if we find a difference in spatial reasoning ability between men and women, is that difference because they're men and women, or is that difference because maybe something else, maybe the way they were treated? Maybe the way women are treated different than men will result in it. Maybe the education is different. You see that in math, where teachers, even teachers who are aware of this bias, teachers tend to focus teaching more on male students of math than they do on female students. Even though we know for a fact that there's no actual gender difference between males and females in ability, there is differential treatment in math classes between males and females. So what you result in there is non-equivalent groups. The equivalent groups are because they're in two different groups that the researcher hasn't chose who goes in what group. They are groups that are pre-existing, and because of it, the groups likely received different conditions leading up to that, the different environments leading up to that. But then let's say we wanted to test instead, we're wanting to test two different drugs in this case. But we're testing these two different drugs, but we give them one to the pre-existing group 1, one to the other to the pre-existing group 2. Well, the differences then between them may be due to the non-equivalent groups factor, the pre-existing groups factor. Or it could be due to the treatment. So it really just comes down to when we're doing this non-equivalent groups design between subjects, it is much more difficult to analyze the results because of the fact of internal validity issues. So instead of getting and looking at one condition and a second condition for a different group, it's the same condition for both groups, and then you can test to see if that pre-existing group definition is what's causing the differences rather than the treatment condition. So when we're talking about fully non-experimental design with non-equivalent groups, research study that just compares the pre-existing groups, the goal is to establish the difference between those pre-existing groups. Just like I was just saying, when we're trying to see if there's a difference between, let's say, males and females on something. This is what's referred to as ex post facto design because we are looking at differences after the fact. What I mean by that is differences after the group selection has been made. And again, as I've said quite a few times, we can't, as a researcher, assign people to these groups. So if we're looking at, let's say, the difference between pregnant women and non-pregnant women, it's ex post facto because it's after they've gotten pregnant. It's after they've self-selected themselves into groups. So some groups participants self-select themselves into, some groups are just by default, for instance, when we're talking about differences in gender. So one way to do it is to look at this as the post-test only non-equivalent control group design when we use pre-existing groups. So one group serves as a treatment condition, a second group of similar but non-equivalent participants is used for the control condition, but the big thing here is there's no random assignment to groups. So if we're trying to see, let's say we're trying to see if pregnancy causes or if pregnancy is related to increased moodiness. I'm going to get really controversial here. But we're trying to see if pregnancy results in increased moodiness. Well, the group that is the control condition is the non-pregnant group. The group that is the treatment condition to see if that's what's going on is the pregnant group. So what you've got here is you've got a control and treatment condition, but at the same time, it's non-equivalent groups and we didn't assign people to groups. So it could just be, there's a factor that causes people to want to become pregnant. And that is the factor that causes moodiness, not the pregnancy itself. So we have to be aware of that when we're looking at this. Looking at quasi-experimental design. So again, if you'll recall, quasi-experimental is where we get even more close to a true experiment, but we've still got non-equivalent groups. So we've got groups we didn't assign to. But what we're going to do here is now a pre-test, post-test, non-equivalent control group design. And what we're doing is we're comparing these two groups, where we've got one group that's measured twice, once before treatment is administered and once after. Let's say we're trying to see if Tylenol reduces pain more in women than it does men. So what we do is we measure a pain level before treatment is administered, before Tylenol is administered, and we measure pain level again after it's been administered, but we do it first in the female group or the male group, whichever one. Then that second group, let's say the first one was a female, the second group, the male group, measured at the same time, but doesn't receive the Tylenol. So it's, in this case, so as you can imagine, there is a lot of threats to internal validity for these non-equivalent group designs because of the simple fact of the individual differences that are present in the different groups because they've been assigned basically by themselves or biologically or whatever it is that's assigning them to the groups. The individual differences can then preclude clear cause and effect explanations. Because the groups have different participant characteristics and there's no random assignment, there's no assurance of equivalent groups, and there's no assurance that we can look at a cause between the treatment condition and the outcome variable. So when we're looking at within subjects design instead of between subjects design, it gets a little bit easier. But again, with the within subjects design here, we're looking at just one group that's measured before and after treatment. And this is the pre-post designs. So this is going to be just like when we talked about the within subjects design in the previous sets of slides, but now we're looking at it when we're looking at only one group that's measured in our pre and post. So we don't have a comparison group. And because we don't have a comparison group, for whatever reason, we could have those threats to validity that we talked about with the pre-post design that we don't have ways to correct for, like we did when we were talking about the pre-post within subjects design we were talking about before, whereas one group can get one drug first and then another, and they can swap them around. You can do them a bunch of different ways. Well, with this quasi-experimental design, those threats to internal validity are there without a real way to get rid of them. Or without a way to get rid of them as easily as when you've got multiple different groups. So there is ways to get rid of them, but it's not as easy when you're looking at multiple groups. So these threats to internal validity here: history, instrumentation, testing effects, maturation, and statistical regression to the mean. So just to restate that, in terms of what we were looking at there when we're talking, especially with the non-experimental design. Not quasi-experimental, but non-experimental. The pre-test, post-test design, the research study, just looking at a series of observations made over time for one group of participants. There's no control or very little control, and because of that, you can get some useful pilot information. However, this non-experimental type design isn't something that is going to get published or should be published. It's more of, hey, I want to know if this is something I should be looking at. And that's what you see often in research is pilot studies that occur. So pilot studies are studies that happen before the actual research, where when you do it without much funding, or you have a little bit of funding for a pilot study, and you run the pilot study and you try and test to see if what you're looking at actually has an effect. And not an effect statistically, but an effect on the surface. An effect meaning, hey, this is something that I can dedicate some time and money to running a better, either a quasi-experimental or a true experiment with. So let's now look at the pre-test, post-test, non-experimental for quasi-experimental designs and how this would work. Because for quasi-experimental, what goes on here is that there's a series of observations. Basically, instead of one observation as pretest, you've got a series of observations as pretest. And because you're doing this series of observations as pretest, instead of just one observation, what you can do is you can start to see trends in the data. You can start to see if the data is doing what it is as a result of just things like maturation or practice or fatigue, or regression to the mean, things like that. Because you're doing this series of observations, if the series of observations are all the same, you get no difference. Let's say you do 2 different observations, or let's say 4. We'll go with a big 4. You do 4 different observations before you administer treatment. You give those 4 different administrations, and no changes between those 4. Then you give a treatment and you do 4 observations after treatment. And there's no difference between the different observations after the treatment, but there is a difference between all of the ones after and all of the ones before. Basically, let's say we're talking about pain, and you measure their pain an hour before taking the drug, 30 minutes before taking the drug, 10 minutes before taking the drug, and in all of those cases, their pain's a 9. Then you give them the drug, and then you measure their pain 30 minutes after, an hour and a half after, and all of their pain measurements are a 7 then. Well, their pain changed, so there was no trend in the data. The trend that was actually in the data is it stayed the same. But let's say on the other hand, you've got this before measure, these 3 before measures, and pain went from a 9 to an 8 to a 7 in our 3 different measures. And then your post measures 30 minutes after, you're at a 6 now, a 5, then a 4. Well, was it due to the drug or was it just something that was going on over time? And that's what these multiple or time series design can do, is it allows you these multiple observations both before and after, so that you can see if these if there's existing trends in the data. For instance, it's possible to see trends in the data that exist before treatment was administered. If you make multiple different observations before treatment, we got 3 different observations here before treatment, you see that there's a general trend going up. So if you didn't administer the treatment, you would expect, if that is the case, for it to keep going like that. Well, when you see the after treatment, you can actually see here that that's what's going on. That you see this, that it continued the way it was. So what's going on here is likely not a treatment effect. What's going on here is likely that it's just general maturation, whatever was going on, because the treatment doesn't look to have had effect on the trend, on the way it was going. Let's look at cross-sectional now. So cross-sectional designs with non-experimental designs. If you recall, cross-sectional is a design that's used when you've got different groups of individuals at different stages. Something is different with the different groups. So you're doing a cross-section, you're examining each group individually and then making comparisons between the groups. This might not seem like an issue, but let's say we were looking at age as our thing for cross-sectional. So we are looking at, let's say we are looking at 20-year-olds, 30-year-olds, and 40-year-olds, and we want to see if there's a difference in internet behavior in 20-year-olds, 30-year-olds, and 40-year-olds. Well, each group is going to represent a different age category, and this is a cross-sectional design, meaning we're looking at these different groups, but again, this is non-experimental. Why is it non-experimental? Because we didn't assign people to be in these groups. We didn't assign people to be in the 20s group, assign people to be in the 30s group, assign people to be in the 40s group. They're already pre-existing, their age is pre-existing, so they got assigned to groups based on their pre-existing conditions. And in this design, in the cross-sectional design, each of the different groups are measured at one point in time and then compared. So I measure all of them, the people in their 30s, people in their 20s, 30s, and 40s. I measure all of them on their internet usage or their acceptance of the internet, and then I make a comparison between them. This is a between subjects non-experimental design with non-equivalent groups because the groups have already been assigned, and it's between subjects between different groups. So what are the strengths and weaknesses of this? Well, the strength is data can be collected over a short period of time. We can observe how behavior changes as people age without waiting for subjects to grow older. If I need to know how internet usage is now, I can figure out how internet usage is right now. I don't have to look at people over periods of the same group of people over a long period of time. I can just get different groups of people to go in each category. However, there are other factors other than age that might differentiate the groups, such as generation effects or cohort effects. In my example here, where I'm talking about the internet, well, those in their 40s, when they were in their younger years, there wasn't internet. So of course there's going to be different views on different ages on the internet there because of cohort effects, because of an effect of the people at that age had different childhood, different experiences growing up. And even when you're looking at the difference between 30s and 20s, you can get that as a fact. So the cohort effects can really mess with data when you're talking about cross-sectional, because cohort effects can be the explanation for the difference, not age as a difference. If you're trying to see if it's age that does it, you're not going to be able to say that age is what is causing these differences, because again, there could be something other than age that's causing it, like when they grew up. And you actually see this in Other things like, let's say we wanted to tell if there's a difference in people in different countries, how they view something. Well, you're going to have different cohort effects or different effects of the people from different countries based on their experience, things like that. So that can be a detriment to these. So before we talk about what's on this slide, we have to next talk about longitudinal. So longitudinal designs are designs that are there to measure age effects, but they're there to measure the same participants at different times. So the example I gave before is we were measuring 20-year-olds, 30-year-olds, and 40-year-olds on their internet usage. But we measured all of them at the same time in different groups. Well, if I measured the same group in their internet usage when they're in their 20s, their internet usage when they're in their 30s, and then their internet usage when they're in their 40s, yes, it takes 20 years to test this, but we could test the same participants over and over again. That's a longitudinal design. A cross-sectional longitudinal design is actually pretty interesting in that it mixes the two. So in this, it's going to take, let's say we wanted to measure people in their 20s, 30s, and 40s, but we measured them in the year 2010. So we've got the year 2010. And we measure people then in their 20s, 30s, and 40s. So we've got 3 different groups. Now, in 2020, we go back to these same participants. We're doing longitudinal now, but we're also doing cross-sectional because we're looking at multiple different groups. But now we measure this group 1 in their 30s, this group 2 in their 40s, and group 3 in their 50s, and we're going to add a group 4 that are in their 20s. Now in 2030, we go back to these same participants. Now we measure these in their 40s, 50s, 60s, 30s, and now we get another group that we measure in their 20s. As you can see, this is a lot of work to do, but we eliminate the problems of our cross-sectional because we're looking at it now longitudinally. But we're getting more than just the data going from here to here, because if we wanted to just do a longitudinal, we'd just do this one group. But because we're doing other ones, we're doing other groups like the 30 to 40 and 40 to 50, we can now control for certain factors like certain maturation factors that might occur. So this type of design, it really examines the development of phenomena other than individual aging because it's looking at not just what's going on with aging, but it's looking at what's going on here as well, because it can measure what's going on here. Here we've got 4 measurements. It can measure what's going on here as well as what's going on with the aging. So what are the strengths and weaknesses of the longitudinal design? We're not talking about the cross-sectional longitudinal, just longitudinal design. The main strength is there's no cohort or generation effects because we're measuring the same participants over and over. We can control for these cohort or generation effects so we can assess individual differences. However, there's some pretty big weaknesses. Time consuming. Longitudinal is very, very time consuming. I just gave an example where it's 20 years between first participants and not. There are studies out there that they tested people from birth to death. So there are longitudinal designs that have been going on for 90 years, 100 years, where some of these longitudinal designs have been going on. The researchers who started it are long dead. Some of the researchers who took it up in the middle are dead. But the point is these labs are doing these longitudinal designs and going long periods of time. And because of that, you get a lot of attrition. This attrition here. When you test people in their 20s, then their 30s, then their 40s, let's say you start with 100 participants in their 20s, by their 30s, you might be down to 75. by their 40s, you might be down to 40. So you've got a lot of attrition that can occur between these. And there's also potential for practice effects, especially when these are the tests that we're doing are closer together, because they get used to doing these tests. That is one thing I've been using the long-term longitudinal, but longitudinal just means anything over time. I could test people this week, next week, and 2 weeks from now, and that's technically a longitudinal design because time has gone on. The longitudinal designs are usually much longer than that. So let's get to the next learning objective and the final one, identify the statistics and terminology of the non-experimental and quasi-experimental design. So here we're looking at what stats are being used and what terminology is being used. So for non-experimental and quasi-experimental research, just refer to the between subjects designs and within subjects designs that we already covered. It pretty much just continues on. We talked about some non-experimental with it there, but really the big thing there is that there isn't too much difference between quasi-experimental and true experimental with between subjects and within subjects, other than we're not having true experiments. We're not controlling for all internal validity, but we use the same stats and the same terminology for this that we would for that. If we've got two group designs, we typically do t-tests for means. We can do single factor ANOVA, analysis of variance. If we've got non-numerical data, if we've got a nominal data, we can use chi-square tests. It's pretty standard in the tests that we do there. If we're doing a pre-test, post-test non-equivalent control group design, we could do a two-factor or mixed design ANOVA. But really what it comes down to is when we get into these harder ones, these more complex ones, you can use SPSS or any of the other stats programs, and there's many different tests that we can use or things that we can do to test to see if the trends in the data are there. As far as terminology goes, so again, we talked about independent and dependent variables before and how those work and what's going on there. With non-experimental and quasi-experimental, we still are going to have an independent variable and a dependent variable. However, our independent variable is actually titled a quasi-independent variable. Now that being said, it's still an independent variable. It's still going to be labeled as an independent variable. If I asked you in a quasi-experimental design which one's the independent variable, you would still list the one that's the independent variable. You're rarely ever outside of a methods class going to hear a independent variable from our quasi-experimental designs called a quasi-independent variable. It's just going to essentially be called the same thing. And it is essentially the same thing, except the participants weren't assigned to the groups. They came into the groups from pre-existing conditions. So this was a pretty short one, actually a really short one. We started by differentiating non-experimental and quasi-experimental designs. You should now be able to explain the difference between equivalent and non-equivalent groups. You should be able to explain the pre-post non-experimental and quasi-experimental designs. You should be able to identify when cross-sectional design should be used, also identify when longitudinal design should be used. And finishing up, you should be able to identify the stats and terminology of non-experimental and quasi-experimental designs. Thanks, come on back.